This is a laser module. We've all encountered various types of lasers in our lives, but most of us don't know how they work. But in this video, we'll explore the fundamental principles behind these lasers. We'll learn how to integrate this module into our projects, experiment with simple applications, and even create light animations using it. So if you're excited to learn, let's get started. Let's start by checking the module itself first. The laser module 650 nanometers 5 volts is a compact and low-power laser module that emits a red laser beam at 650 nanometer wavelength, operating on a 5-volt DC power supply. This module has 3 pins which are G, ND, VCC, and signal. The signal pin serves as a digital control input. When set to high, the laser turns on, and when set to low, it turns off. Additionally, it supports PWM control, allowing brightness adjustment or blinking at various frequencies. Now let's build a simple circuit to see this module in action. Let's begin by connecting the wires to the laser module's pins, and then connecting the other ends to the power supply. We see that if we connect the signal pin directly to 5 volts, the laser turns on. This is suitable if you want the laser to remain on at all times, but if you want to control it with a switch, you need to place the switch between the 5 volts and the signal pin. Now the laser only turns on when the button is pressed. By using a microcontroller and a few lines of code, we can create any light effects we desire. So let's see how we can do so. First thing we need to do is to define the variables that we are going to use, like the pin number of signal pin. Then we can set this pin to act as output. Finally, in the loop, we can set the output to high for a specific duration and then set it to low again. This will create a blinking effect, and we can control the delay between blinks by adjusting the delay duration in the code. We can take it a step further by adding a potentiometer, allowing us to adjust the blinking speed dynamically using the potentiometer. First, let's connect the potentiometer, and then we can add the additional code to enhance the functionality of this project. Again, we will add the necessary variable to store the received variable voltage from the wiper of the potentiometer, and then configure the A0 pin as an input to read this voltage. Also, we will start the serial communication for printing the received value to serial monitor. Now in the main loop, we will read the variable voltage and store it in our variable. And then we can print it to serial monitor as well. Now, based on the value received, we can create different blinking scenarios. For example, when the value is between 0 and 100, the delay between blinks can be set to 40 milliseconds. You can use this logic to create as many scenarios as you want. For this project, I'll add a few more and then we can review the complete result. We can now see that by adjusting the potentiometer, we can control the blinking duration. Additionally, if the potentiometer is turned all the way to one side, the blinking will stop entirely. You've probably also noticed lasers being used as traps in movies and video games, where they create an intricate network of beams to detect intruders or trigger alarms. These scenes often showcase lasers as a high-tech security measure, adding suspense and excitement to the storyline. With our project, we can replicate a similar concept by controlling the laser's behavior. We can incorporate an LDR, light-dependent resistor, to simulate a security system. This system would trigger an alarm when the laser light is blocked and stops reaching the LDR, effectively detecting any obstruction or intrusion. If you enjoyed this video, please give it a like and subscribe for more exciting projects and tutorials in the future.